Okay, hello and welcome to the Green Business Podcast where we meet exciting climate entrepreneurs. Today I have with me Ananya, Raghu, and Rajesh. They are all co founders of Triolt Energy, which is making high performance, fast charging lithium ion cells. They all have illustrious background. Both Ananya and Raghu have PhD from IIT Madras, and Rajesh is from IISc. uh, Triolt has been around for 3 years. They already have a prototype that is now ready to be tested with clients. So lovely having all of you. Welcome.
Thanks, Bharati, for having us on your show.
Yeah, welcome. And let's start with from the beginning. How did the three of you meet, and what is Triolt?
Yeah. So the foundation for what we do here started early a decade ago. Ananya and I were in IIT Madras. Rajesh was in IIT Bangalore. During our PhD, we are working already on lithium-ion battery cells. So we are friends from that time, and that time itself, early on, we realized that lithium-ion battery cells are key in energy storage space. Be it electric vehicles, stationary storage, drones, so on and so forth. But unfortunately, till today, all the cells we utilize are imported cells,
Right.
because there is no manufacturing in India, and that's where it started. And eventually, as the EV ecosystem and in general startup ecosystem become more conducive than ever, in 2022 we came together and we started the Triolt Energy in February 2022. That's how it started.
Yeah. Okay. Lovely. And like you said, India, there is no one in India who makes lithium-ion cells yet. So why is it so hard to make this in India?
So these lithium-ion cell technology is very complicated. There are interdependent parameters. There are so many, more than 100 parameters. And it's also important to understand deep chemistry involved in this cell. It's not very similar to typical electronic or electrical component. It's not a linear at all. So in general, electrochemistry is very complicated. So since we have a deep background in understanding, starting from the materials, then making the electrodes and making the cell, designing the electrodes or materials for fast charging or energy density, this helped us to sort of design and develop cells. So this deep understanding is important if you were to come up with this technology.
And what are the other barriers? Like, why don't we have anyone yet who makes it at a commercial levels?
Now there are some companies that are coming up, but again, as I mentioned, the technology development is difficult part. So they are trying to sort of purchase technology from other companies from abroad, and they're trying to set up a big practice directly. But I'm afraid I don't know if they will get a current generation technology if they're purchasing from different companies. And also we have seen a few years ago there are some fires happening with the batteries. That is mainly because the chemistry or the cells developed are not exactly suitable for Indian conditions. Usually we have hotter climates here. That's exactly we are trying to solve. So we have designed our cells so which can operate at higher elevated temperatures and still have that can charge in shorter times.
Yeah. Okay. So tell me more about your innovations. Your cells charge faster, right? So charge faster means basically ions move faster, right? So what is So what is it that you have innovated on? Tell me more about those things.
Yeah. We deliberately chose a more challenging chemistry to begin with, and specifically optimized for fast charging. So knowing if we can master for that particular chemistry, we could adapt for other chemistries as well. So we started with NMC chemistry. We understand like NMC chemistry for fine tuning for the fast charging is the most challenging. So once we have done it, that we have mastered it, now we could do with all other chemistries. So we are not stick only for the NMC chemistry, we are also working with multiple chemistries. Rajesh will tell about more about the innovation part. Yeah, Rajesh, please go ahead.
So our core technology lies in the enabling of the fast charging, as Raghu mentioned. Especially our cells are working better in the high temperature environment that we have tuned certain parameters in the cell. The key innovation lies in the proprietary electrode materials, electrode processing, and this design. So these are the important parameters where we are tuning to enable the fast charge of this. And this is in something that somebody can replicate easily. So it's you can't even reverse engineer. It's quite difficult because it's involving deeply embedded in the process know-how. So that's the key challenge here, the key aspects.
So innovation is the cathode material, right?
It's not only cathode, it's in the all the design of the electrodes, processing anode and cathode, also the cell design.
Yeah, so it includes anode, cathode both, and then cell design as well. So it's at the multiple fronts.
Yeah.
And that's it also difficult. Even though we cut open the cell and do characterization, it's very difficult to understand what is the engineering part, what are the design part is done.
Right.
So starting, as Raghu mentioned, more than 100 parameters we are optimizing. So that right from the material, so how you bake the material, from there it starts, and which vendor you choose it. So your experiment starts from you select the vendor and you fine tune the materials and then you process it. So it's multiple level of innovations are involved. Even for a cathode, anode, and even in the electrolyte, you have to find out which electrolyte is suitable for that particular material. So there are different sets of innovations in the processing level, and also different levels of innovations on the design level, where you can fine tune the electrical and the thermal conductivity, and also control on the electrode plating. So these lithium plating. So these all innovations are involved in the cell performance. And also you have a better understanding on the electrochemistry aspect, how the cell works, and also you should have a good understanding on how material works. So this you should be able to connect the material aspect and also on the cell aspect. Then you can go ahead. Yeah.
So when we are trying to fast charge phone, for example, we can also fast charges, we can quickly charge our phone or slowly charge our phone depending on the charger, right? So some of the fast charging of the battery can also be enabled by the infrastructure or things other than cells, right? So what are the key limitations to that, and how does having a cell that charges fast help?
Not exactly. The charges is something like you provide the current for the system to charge. So you can do fast charge one way, like if your cell is designed for fast charge, you don't need to worry about the charging station or anything. You can straight away pass the current and charge it. But at the same time, the cells available in the market is not supporting for the fast charging, because once you try to charge, the heat will generate. So you can't, the cell will be having some certain condition, it can't charge beyond 60 degrees or something. So it automatically cut off. So what they are doing is they're cooling externally to remove the heat from the system, so that the system will see that the temperature is not beyond 60. So you will try to charge it. But at the same time, if you try to do like that, you can't predict what are the side effects are happening inside the cells. Because we also tried with cooling the market available cells, we try to cool and charge, but we see that you can charge it, but at the same time the cell behavior is not exactly the same as the cell behaves in the lower current. That means you are pushing the cells for the fast charging by external cooling. But I can say that there is a side effect inside the cells. You can't predict how it can evolve when the year goes. So you can do it some extent, but it is not, I would say, like the cell has to be designed for fast charging. That is a better way to approach the fast charging. And if you provide an external cooling, that aids the fast charging in a better way, but not like only do the cooling and do the fast charge.
Also, there is another possibility of a degradation of the capacity when you do, So that's what every cells you can't do the fast charge. You have to specially design for that cells to be fast charged.
Okay.
And the existing cells in the market, if you try to fast charge them, the cells which are supposed to work for 1,500 cycles, they work only for 500 cycles. The capacity will degrade rapidly. And that's exactly our innovation solves.
Okay, so
your chemistry, you can see the difference in the performance. If you see how the curve appears when you try to cool and fast charge, and when you try to fast charge a normal cells without cooling, if it is already optimized for fast charge, it's entirely different.
Okay. So when the cell is optimized for fast charging, it can sustain both fast charging and the cycle life. That's what you mean.
Correct.
That's good.
And what have you optimized for? Like, what is that, and how does it compare with maybe what is available in the market or in China? You choose whatever is the standard.
So as Rajesh also mentioned, so there's innovation starting from the processing of the anode as well as cathode materials, their design, and then how do we match them and arrange them in the cell design also.
Right.
These are multiple inventions we have, and these inventions are chemistry agnostics. So we have done it for NMC. We can also implement similar strategy
For
be it LFP or sodium-ion chemistries as well, with a little tweaking. So we can also do fast charging innovation in the other chemistries as well. And now with this technology, sorry, last part of the question was what?
So the part is that with all this innovation, you have optimized for the cycle life and the fast charging both, right? So what are those standards that you are hoping to accomplish, and how do they compare with what is available in India or China or wherever you think?
So we have done like our cells compared with the commercials of the different brands we have done. Especially as I mentioned, the focus was on how do the cells work at elevated temperatures.
Right.
So we have our cells and the 3-4 different repetitive brand cells. We have placed them in a 45 degrees ambient temperature in a thermal chamber, and we have applied fast charge rates. We have charged cells within just 20 minutes. Our cell, I think it has seen only a 4 to 5 degrees increment in temperature from 45 to 50, whereas commercial cells, I think 2 of them, they directly shoot up beyond 60 degrees, so you cannot operate them at that rate because it's going out of their safety range.
Right.
And the other cells, they are degraded just a few hundreds of cycles, whereas we have seen a cycle life of around more than 1800 at 45 degrees Celsius. So when you compare the our cells with the commercial cells, that too with the premium cells in the market, so we are at a pretty good stage. I mean, we are at par with those.
Right. Okay. And you have customized for Indian conditions, which is basically hot weather.
That makes it work well at elevated temperature with a negligible impact on the life of the cell.
Right. And where are like when someone decides to start doing this, what are the various milestones? Like, this is going to be a long journey, right? 6-7 years until it commercializes. So what are the different milestones that have been there, and where you are, and where do you see yourself in like maybe 2 years?
Yeah. So in 2 years, I would say like maybe a few months down the line, we are looking for establishing 50 megawatt hour line. That's our immediate target. To 25 to 26, we want to establish a 50 megawatt hour line. So that we see that the ecosystem is growing very organically. So we are not, we don't want to jump into that, or we don't want to take a very quick decision. We want to see that how the market pick up, and so how the market see that. So accordingly, we want to grow organically. So we see that first we establish a 50 megawatt hour line that can serve for around 16,000 bikes when we consider like a 3 kilowatt hour battery pack. So we see that how the market growing, and how people are taking the fast charging system and the adaptability. So because once we grow, we are coming up with a very cutting edge technology. So that you can see that in the global also, it's a very competitive technology for the fast charging sides of the cells. So we want to see the ecosystem will be in place. That means the public charging station should be there, the supporting system should be there. So we take a call for a 50 megawatt hour line to establish first, and then serve, and then ramp up to 500 to giga scale. There we see a joint venture or technology transfer, which is feasible. We have to take a call after that.
No, but where are you now? So you already have, and how many milestones? More importantly, how many milestones did you have to cross to get here?
Yeah, we are now in the field trial stage. So we already made our cells. Now we are scaling up our cells. We have the capability of more than 200 cells per week. So the thing is, now the cells are there, and we check the repeatability of our product. Reproducibility is there. So these are the milestones. First, your innovation should be in place, and you should get a reproducibility in your product. So that we made sure. So once you get the reproducibility, you can scale up your product. So we understand. We started with 500 ml beaker, 500 ml mixer, where we started. From that, we ended up now we are 7-liter mixer. We are doing it. So we understand when we make changes, when you scale up, what are the challenges we have to face it. And in our product, we see from 1 to 2 AH cells, we are making now 7 amp-hour cells. So we see clearly the reproducibility in our product and scalability and consistency in the performance. So the cell level, we have done it. Now we have to take these cells for the testing in the vehicle. That's what we are doing now. Once we finish that in the testing in the vehicle, we are sure that we can just scale up the product. That's what we are saying, like 50 megawatt of we have to establish and start the commercial scale.
So I mean, to put it in a simple way, we are conducting field trials with our cells right now. Scooters, electric scooters. We already spoke to a few OEMs. I can't name them right now. We have already spoke to them. They are also ready to take our samples and test them as a OEM validation. So that is going to happen in maybe a couple of months of time. Once that is done, so we should be having qualification feedback from the OEMs as well. So with that, we are already started raising for establishing 50 megawatt hour line. So that should be able to help us to enter at least the market. We can serve 1,500, 1,600, so 16,000 bikes per annum. So that will help us to prove our cells or our product in the market. From then we can grow to any size, making JVs or whatever comes forward. So that's what we are thinking right now.
Okay. So let me summarize it. You have cells that are ready to be tried on field. These are fast charging cells, lithium-ion cells with NMC chemistry. You are capable of doing, of course, other chemistries as well. And it seems to me that your target market is two-wheelers. Is that right?
Presently, we are targeting two-wheelers, but our product can also go into four-wheeler, drones, or any other special applications as well.
And will it be possible for you to talk about how it compares, like how your cells would compare with what is available in the market in terms of cost and in terms of performance?
The cost actually we are actually looking to compete with the market price in a product scale. So right now we have in a pilot scale, a small scale, which we really can't come. So of course in a production level, it will be compared with the market price. And additionally, we are offering the features like the fast charge capability and the long cycle life, etc. So we are actually giving a premium quality cells.
At the same
market.
The same as the conventional.
I would say, like, since it's a B2B business, so if you say, no one will say like what is the cost they are getting it. So it's like it's always a matter of the volume. You see, like how much volume you give, and so there it depends on the cost. So it varies from the numbers and all this.
Right. And so far you have come. You already have your pilot facility, right? Pilot facility. How did you manage all of that? How was it funded? How did you get not just funded? How did you set up the infrastructure? Talk to me about that journey.
We started in IIT Hyderabad with the Nidhi Prayas grant, and then later on we got to be supported by METI, and we also won the FLCTD Unido challenge, and we secure a commercial contract. So there our journey started, and as I mentioned earlier, we made a cells of 1 to 2 amp hour cells, initially, and then we started even whatever is available in the market that can charge in 2 hours, something like that. And then later on, we fine-tune the cells that can do the charge in 15 to 20 minutes. And then now we are in a position of making around 7 amp hour cells that can do the fast even in the higher temperature. As earlier they mentioned, 45 degree, we literally kept the cell at 45 degree and we had done the cycle life test in that. And we also, then around mid of 2023, we moved to the IITM Research Park. We see that the ecosystem very much fit for our way of hardware kind of startups. And so we moved to Chennai, and now here we established 50 kilowatt hour line. There, as I mentioned, we can produce more cells now and we can do the testing. And we are also supported by IITM RTBI support. They supported with a grant, and for establishing the 50 kilowatt hour line, we got two pre-seed support from Little Angel Network and Campus Angel Network, along with SIDBI. So these are our investors now, and now, okay, yeah, that's all about.
And what was the hardest in this journey till here? Where did you spend most amount of time, all of you?
I think, of course, Ananya highlighted the important milestones and things, but there are several days where there is a lot of hard work put in. There are several hundreds of experiments we have conducted to reach the stage of maturity of the technology. But again, that's what we do day and night. I mean, day in and day out. So that's what we have been doing from past, I think, 14 years. So we could manage it. That's what we have done throughout our research career from 2012 onwards. So that was okay. And then, of course, fundraise is what is important. So that's what Ananya mentioned. So the grant from DST, Nidhi Prayas and BIT, IITM really fueled the journey.
Okay. And from here now, there is going to be testing, and then there is going to be a commercial setup, right? What are the next 2 years looking like? And do you feel OEM will be the only market, like scooters will be the only market, or there are other avenues as well?
Well, right now as a startup, we want to focus our energies in one aspect. So we go one step and then one step. So we can't really afford to diversify everything at present. So two-wheelers is what we are targeting right now. And then, as I mentioned earlier, also our technology is chemistry agnostic. We can also implement in LFP as well as sodium-ion cells as well. So we will diversify after entering into two-wheelers. And coming to the customers, of course, OEMs are our go-to customers, the primary customers. And then, since we have fast charging technology, fleet operators is more beneficial. So OEMs who are making vehicles for fleet operators, they are also right customers for us. After that, we are also looking at a drone market as well.
Okay. And three of you, how the roles are divided amongst three of you?
So I'm the CEO of the company, and Rajesh is COO. Ananya is managing director of the company, and Ananya takes roles. Maybe probably you can explain.
Yeah, I am talking to the stakeholders and try to understand how the market evolves and what are the things we have to say. So it's all over, like we divided initially the kind of implementation one part and procurement other part, and talking and understanding the investor's perspective and the market dynamics. So we see that each one is allocated mostly on that. But at the same time, since we are a small company now and with limited people, so we three intensively work on the technology now.
And basically, I lead the strategy, product development, and how do we move forward with the product and what are the next stages, and the back work and taking care of all the aspects for going to the next stage, like which is production.
Right. Yeah. And in terms of risks, this is to all three of you, and this is the last question also. What do you think are the key risks that are going to be there for you next 2-3 years?
Yeah, the important risk is as Ananya mentioned, the supply chain. So you know that in battery field, none of the battery materials are producing in India. We have to depend multiple countries. Now slowly it is evolving in India. So we have to establish a robust supply chain for all related materials for battery. That's one of the key important aspects.
Right.
And another important is the technological challenges. So emerging technologies. See, the batteries are highly evolving day to day. So there's technologies are arising. You have to have a strong R&D to focus. It changes, you have to adapt easily, and you have to test all those things, and it takes time also. So that is one of the other aspects, because battery research is something like it takes long time.
Right.
So you have to be very competitive. What is changes happening in the around world, the fast charge is one of the aspects. So like that we have to adopt quickly. So these are and other important is environmental impact, and we're concerned over the material sourcing and the battery recycling, etc.
Yeah, I mean, among all this, technology is the critical aspect, because as I mentioned, there are so many components in a battery cell, like be it separator, anode metal, cathode metal, current collector, the housing itself. There are innovations at multiple components. So whenever the innovation, you want to implement that so that your product is up to date. So a constant R&D is definitely a critical aspect. So in that, I think since we are from that background, and we are
it's easy.
Company in that aspect, I think we are so fortunate.
Nana, you want to add?
No. Yeah,
I think they covered. Yeah,
that's very well. So
all right then. Thank you so much. It was lovely seeing all three of you here. It was good meeting you, Rajesh. We didn't meet last time, and thank you so much.
Thank you so much.
have a good day.
Yeah, bye.